Welcome to the second part of today's lecture. In this part, I'm going to move beyond fundamental criticisms of the assumptions underpinning social psychological research. I'm going to talk very specifically about whether the field succeeds on its own terms and how we can do better. For that, it's important to remember the aim of mainstream quantitative social psychology. So the aim is to discover fairly universal relationships, because recognizing that there will be cultural differences, changes over time, but still we aim to be able to state conclusions that hold true across multiple contexts. And that means that we should be able to predict the outcomes of future experiments. If you run an experiment using identical materials and identical procedure, a similar group of participants to what I used, you should get the same result. However, that assumption was put to the test with the reproducibility project in 2015. For that project, some leading psychologists selected 100 important studies and tried to replicate them as closely as possible, so sticking with the original material, the original procedure. And we would expect that most of them yield the same result as the original studies. Of course, some will always be different due to random sampling error. But what did they find? Well, they found that rather few yielded a comparable result to the original study. On the x-axis, on the bottom, you see the effect size of each original study. The further to the right a point is, the stronger the observed effect was. On the horizontal axis, you see the effect size in the replication. And already we can see that almost always the effect size of the replication was smaller than the effect size that was initially observed. And that's a problem, because effect sizes tell us how important an effect is, and in practical terms, whether something is worth paying money for, investing resources into. If I estimate that a certain teaching intervention has a huge effect, while in fact it only has a small effect, that can lead to wrong decisions. But maybe more worryingly, the colors of each point are indicating whether the replication achieved a statistically significant result. So the green points are what we would expect. There was a significant effect in the initial study, and that significant effect showed up again in the replication. All the red points are situations where a significant effect did not replicate. So only 1/3 of all the studies yielded significant results again. The effect sizes were reduced by 50% on average, and social psychology did worst. In social psychology, only 1 in 4 studies could be replicated. These findings triggered lots of discussions. There was also some criticism of the methodology of the initial project. So Many Labs 2 was a follow-up initiative to again look at psychological studies, this time with huge sample sizes, so to really make sure that they would find any effect that was really out there. And still only half of the studies they looked at could be replicated, and the effect sizes were once again much lower. And this doesn't just affect some random studies, but it throws doubts on some social psychological findings that have been taught and publicly discussed a lot. So one of them is the idea of ego depletion, where it has been said that if you have to resist some temptation, it becomes harder to exert self-control later on. So if you're sitting in front of a table with lots of sweets and you resist the urge to eat some sweets, that will deplete your self-control on a later task. Some very impressive initial findings have not been replicated. So it doesn't look like that effect is strong, at least. Maybe it just doesn't exist. Social priming is a similar field of research with fascinating findings, where the initial studies suggested that if you hold a cold drink in your hand, that will lead to you evaluating other people as having a cold personality, while a hot drink will lead to the opposite. Again, replications are very inconsistent, so the picture is at least a lot more complicated than what we would have expected from the initial studies. The famous marshmallow test about the importance of self-control in children for all kinds of life outcomes has been thrown into doubt through replication, and all the stereotype threat that I taught you about has been complicated by replications. In that field, I think there is still some evidence that there is a real effect, but there are various replications that have at least qualified that. If you want to read up on an interesting example of that debate between proponents of a theory and those who fail to replicate it, stereotype threat is a good example where both sides have good arguments about what we should make of the evidence. In any case, these are just some examples of findings that we shouldn't be too certain of anymore. And it's not because one replication failed. The insight from one failed replication is limited, because any study will arrive at a conclusion that can match reality or not. So this analogy to a criminal trial might help to clarify things, where either the defendant is guilty or innocent, and then the defendant is either convicted or not convicted. And clearly, often that goes right. Innocent defendants are not convicted, guilty defendants are convicted, but it can also go wrong in both directions. We can have innocent defendants who are convicted, which is then a false positive. And we can have guilty defendants who are not convicted, a false negative. In statistics, with regard to hypotheses, these are called type 1 and type 2 errors. Type 1 errors are wrong conclusions that there is an effect. Type 2 errors are wrong conclusions that there is no effect. And we tend to be more concerned about type 1 errors than type 2 errors. And there's a trade-off there that is ultimately indicated by the p-value, or by our criterion for the p-value. We set it at 0.05, and what that should do is it should ensure that we have a limited number of false positives, and in exchange we accept a somewhat higher number of false negatives. Of course, having a big sample size then again helps to reduce the number of false negatives, because it gives a study greater power to detect an effect. But we would expect that there are somewhat more false negatives than false positives, which then indicates that we shouldn't be surprised that some replications fail, because that might then be just an instance of a false negative. However, once you have several replications that fail to show an effect, it's very unlikely that that's just due to chance. And especially many labs too, the latest large replication attempt used huge sample sizes, which makes type 2 errors, false negatives, quite unlikely. So don't trust one replication to definitely refute a finding, but when there are several failed replications, there's definitely a strong reason to be cautious about any initial finding. One further thing to consider is that there are different types of replications. What we might think of most often are direct replications, where someone attempts to exactly replicate an original study. So if we wanted to do this with Ash's line experiments, we clearly would need to use lines that are similar in length to the original ones, where participants have the same distance to those lines, and where we again only recruit male psychology students to make sure that the sample is directly comparable. It would be a direct replication. If this now were to fail several times, we would be warranted to conclude that the original study probably was a false positive. In the case of Ash's line study, that's not the case. Replications tend to work, but that's the insight we can derive from direct replications. An alternative idea is to run conceptual replications. So in this case, we might get together a mixed group of men and women from various backgrounds and get them to identify which inside of a fruit matches the outside. And here the idea would again be that it's quite a simple task. So if someone goes along with a majority that gives the wrong answer, we have some indication of conformity. Importantly, if this doesn't work out, we don't find an effect here, this doesn't allow us to refute Ash's initial study. However, it might give us very helpful information about the situations under which that effect arises. So conceptual replications are really good to support theory building out of an experiment, but they don't help us very much to figure out whether the initial experiment was a false positive. Obviously, in reality, that distinction isn't always clear-cut, and it can be very difficult to run direct replications because of some of the things I discussed in the last video. Research is embedded in a social context. So if you replicate my experiment, you're doing it in a different political climate, in a different season. So there are many potential factors that you can't replicate directly. So when you look at the debate between researchers who put forward a theory and those who fail to replicate it, it's quite often about these differences, where original researchers say your replication wasn't direct, so it doesn't really address my study. But then when you read it, it's important to think about whether the differences are important. And if they are, what we can learn about the conclusions of the experiment if the season of the year actually makes a difference to the outcome of the experiment. Still, even if we just look at direct replications of studies that can be replicated directly quite well, because they can be easily run online with exactly the same questionnaire, with similar type of participants. In those studies, we still get far too many failed replications, which indicates that we have too many false positives in our social psychology literature. Why would that be? One aspect, certainly, that some researchers fabricate data, invent data. Based on everything we know, that's rare, but it's something to be mindful of. It's certainly a possibility. But more importantly, there's some habits in data analysis that are very problematic. There are some issues around publishing. And finally, there are a couple of issues with the statistics we use, and I'll talk about those in turn. So starting from data analysis, one of the things that has been debated the most is the notion of p-hacking. The idea here is that a p-value only gives me valid information related to my risk of publishing a false positive if I take my data, test my hypothesis that I came up with before, and then move on. P-hacking describes the process where people try to optimize the p-value, try to get a good p-value that's under 0.05, where we can then happily conclude that we have a significant finding. How would you do that? One, so-called slow p-hacking, it's just about tweaking your data and your analysis methods in a way that's not about making up data. It's not outright fabrication. But it's about excluding a couple of participants who gave strange answers, which sometimes have to do if it's clear that they haven't paid attention or haven't understood the question. But if you do it in order to get your p-value down, then that's clearly inappropriate. You might choose certain data transformations, or you might stop collecting data as soon as you have a significant result. All of those invalidate the p-value and lead to a higher rate of false positives. An alternative approach, it's sometimes called fast p-hacking, is just about running lots of tests of similar hypotheses and hoping that some of them show the effect we are after. So in one of the classes, I raised the example of testing whether drinking beer leads to pro-social behavior. If I now have many different indicators of pro-social behavior in many different brands of beer, I end up with many hypotheses that I can test, and some of them will very likely result in a low p-value. If I then only publish those and just forget about the others, that's a clear instance of p-hacking and a sure way to end up with too many false positives in the literature. Hacking is something similar, where researchers look at the data and then use the data they have seen to develop hypotheses and then test those hypotheses on the data. And that doesn't work because implicitly it's a very similar process. Only testing the hypotheses that look promising in that particular data set is almost like testing many hypotheses and just retaining the ones with low p-values. Of course, we should look at data, we should look at the world to develop hypotheses, but a scientific method then requires us to find new data to test the hypothesis. So hypothesizing after the results are known, that's what hacking stands for, will lead to more false positives. And the final idea is the so-called garden of forking paths, which is just a metaphor for the many analytical choices we have to make in the process from receiving data to publishing results. We need to decide about exclusions, we need to decide about which tests to run, we need to decide about data transformations. And if we do that in order to minimize the p-value, then we are at p-hacking. But even if we don't do that with something like that in mind, each of these many forks can take us down towards the desired result due to motivated reasoning or maybe just due to chance. So it's important to recognize that all of these small choices can add up to create misleading results. Many statisticians have said things similar to this quote. If we spend enough time tweaking our analysis and tweaking the data, a data set can be made. I would say not to confess anything, but to confess quite a lot beyond what is actually warranted to conclude. And that's not just about cheating or pushing your data to show you what you wanted to show. But it's also about recognizing that there is legitimate diversity in analytical choices that can lead to legitimate differences in results. So this fascinating article took a data set and gave it to 29 experienced teams of analysts. The data set was a data set of referee decisions in soccer. And they had to answer the fairly straightforwardly sounding question, at least, whether there's evidence for racial bias in referee decisions. These 29 teams decided how to analyze the data, came up with about 29 different strategies. And those strategies led to different results. 2/3 said, yes, this data allows us to conclude that there is racial bias. 1/3 said, well, we can't make that conclusion, and the effect size is varied hugely. And that's not because 2/3 engaged in p-hacking or 1/3 didn't want to find that result, but it is because the same data can legitimately lead to different conclusions. And that's fine as long as we bear that in mind and don't choose analytical strategies in order to get the conclusion we want. Because then if lots of people do research into this, 2/3 of the papers should say there is bias, 1/3 should say there is no bias, and then you can run meta-analysis and figure out what the overall finding is. But usually you don't give your data set to 29 analysts. Usually you just run one set of analyses or a couple of them, and then you tend to publish the one that favors your interpretation of the situation. And that's not ideal. So when you see a surprising finding, it's quite important to look at the method. And we have more and more open data where you can sometimes literally just download the data and play around with it yourself and see where that leads you, if you can confirm the initial findings or not. One way of reducing the temptation to go down convenient forking path and to engage in p-hacking is through pre-registrations. They're becoming more common, and basically all that they are is a way for researchers to create a public record of their plans before they start. And the plan definitely always includes a statement of how much data will be collected, how that data will be processed, and what specific tests will be run. And if you publicly write that down before you start, it becomes much less likely that dubious practices will take hold afterwards. Usually these pre-registrations are embargoed, so are invisible to the public until your research gets published, or until a specific amount of time has elapsed from the time you started. And of course, it's not a protection against people just faking data or just lying in their analysis. But as said earlier, that is rare. The bigger problem seems to be motivated reasoning and self-serving dubious research practices. And their pre-registrations can help a lot. Another aspect is reproducible research, where we want to make it possible for independent researchers to reproduce the analysis on our data set. So this is not about replication, not someone collecting new data and trying to run the experiment again. It's just about reproduction, making it easy to check our statistical methods and to just try out different statistical methods to see if they lead to the same result. And to do that, to enable readers to reproduce analysis, clearly they need a published article that describes the analysis and results, but they also need the data, ideally the analysis code that was run, so they can just plug it into a computer software and use it, and any additional description that's needed to explain how data and code work together. In some fields of research that has become the norm. In those fields, it's very difficult to publish articles that are not reproducible for the reader and also for the peer reviewers. Psychology is lagging behind a bit, partly because many of us still use SPSS, and that's not great for reproduction because you just click buttons that makes it more difficult to tell someone else precisely what you have done. But it's possible in SPSS, and the field is slowly moving towards statistical programming tools like R anyway. A key moment that highlighted the importance of reproducible research came with this article, Growth in a Time of Debt. That article by Kenneth and Rogoff argued that government debt can be a huge problem and can basically prevent economic growth. It came out in 2010, just after the financial crisis, and provided a justification for many governments to engage in austerity, so to engage in budget cuts, in low public spending. It was cited in the House of Commons here, it was cited by many politicians worldwide. But then a group of master students got curious, asked Kenneth and Rogoff for the data. The data wasn't published, the article wasn't easily reproducible, but they said, we'd actually like to try to reproduce it. And then they found that a substantial share of the effect was based on an Excel mistake. And some economists, like the Nobel Prize winner Paul Krugman, argue that actually the article didn't find a real effect at all. It was just based on this error. And this, well, a silly computer error, led to policies that led to a lot of hardship in the world. Kenneth and Rogoff say that in spite of the error, the tendencies they found still hold true, but that's not the point. The point is that this article that wasn't reproducible had errors in it that couldn't be discovered for a long time because that movement hadn't yet arrived in their field. So those are all things linked to data analysis, and transparency of those. Another aspect is publication bias, because what we are observing is that we have too many false positives in our published literature. And one reason for that is that null findings rarely get published. So in psychology, we are the worst based on this list, in that more than 90% of articles report that they found support for their hypotheses. That either means that articles that did not find support don't get published, in which case it might well be that 20 people have tested a specific hypothesis, one of them found a false positive, and only that one got published. That's the one explanation. The other explanation is that we just engage in incredibly boring research in which we only test hypotheses that are true. And both of those are not great situations. So something is wrong if 90% of articles find support for their hypothesis. And it seems more likely that it is because null results aren't published. In the survey of social scientists, not even just psychologists, the respondents said that 22% of studies resulted in null results, in null findings. But in more than half of those didn't even get written up, let alone published. And it's a problem because it leads other people to repeat research that hasn't worked out before. And it leads to false positives standing alone without true negatives to correct them. One way to combat this is to embrace pre-registrations, because they have been shown to make it a lot more likely for null results to get published. Partly because they make it easier to separate between evaluating the research design and evaluating the results. And if you can evaluate the pre-registered research design and say this was worthwhile, this was a well-designed piece of research, and they didn't find a significant difference, it becomes easier to publish that. An alternative to that is to have more platforms to easily publish null findings. Because they're generally not going to make you famous, they're not great for your career, but still collectively, as a community of scientists, we need to be able to see those. And there's some initiatives like PSY4013 enter the field. It's quite a simple platform to post replication attempts. When students replicate a study as part of their bachelor project, or when a researcher replicates something as a small kind of side project, it can be posted on such platforms. It's then not peer-reviewed if it's just posted there, so it's not the best evidence. But still it's a way to kind of raise a notification light, a warning light, and say, well, if someone says, I tried to replicate that and it didn't work, then maybe we should take the initial finding with a larger pinch of salt than we otherwise would. So if you read an experimental study that you find interesting, it might be worth having a look at Psych File Thrower because they have quite a lot of replication reports. And regardless of whether or not such a report supports or contradicts the study you're interested in, it will add something to your evaluation of how much we should trust the original finding. To wrap up this list of problems, I just briefly want to point out two issues that come through the type of statistics that we use. One issue is that the statistical tests we run all test how unlikely it is to observe the kind of differences that we have observed due to chance. That's what all null hypothesis significance testing, so all the statistics you're being taught is about. But that means that we are not able to easily distinguish between evidence for there being a small effect or no effect and just weak evidence because we have a small sample or bad measures or something that's really related to the quality of the study, while there being a strong effect in the population. So the problem is that large p-values, null findings, on their own don't tell us very much. If we see them, we also need to think about other things around the quality of the study. And additionally, we tend to not consider prior probabilities, which can be a problem when people test very esoteric studies. The replication crisis was kind of kicked off with an article by them called Sensing the Future that presented evidence for precognition, basically for our ability to see into the future. And based on all we know, there was nothing fundamentally wrong with that article. Kind of played according to the rules. But one thing that we just really need to take more seriously are prior probabilities, where if you come up with a very unlikely hypothesis, like we can see into the future, we should expect you to provide better evidence for that hypothesis than if you come up with a rather trivial hypothesis. So that's this idea of prior probabilities. Bayesian statistics can help with both of these issues because it can help us to figure out how much we should shift our belief into either direction, into believing that there is no effect or believing that there is an effect. But it's not yet widely used, and it's something that I hope you will learn about at some point in your future career as psychologists, but we're not going to focus on now. So what to do in order to use these insights from the replication crisis in your academic career as students for now? So firstly, when you like an experiment, never treat that as the final word. Look for replications and meta-analysis, and if there are none, just be aware that it's unfortunately not unlikely at all that it's just a false positive. And that doesn't just apply to experimental findings, but of course also to broader theories. So when you hear about a theory like ego depletion, try to look at the experiments that support it and try to see if there are a couple of really independent experiments that the theory can stand strong, even if one of those was a false positive. Conversely, that of course means that if you have a good theory, it will be supported by multiple experiments. So you can't reject a whole theory just by citing a failed replication. And that might be the case with something like stereotype threat, for example. And finally, in reading articles, I'd encourage you to keep an eye out for these open science badges. Psychologists have been shown to be about as responsive to these stickers as primary school children would be. Many of us really like to get them. But they just indicate that articles live up to some of the openness standards I talked about. The first one, the red one here, shows pre-registration. Second and third are about open data and open materials that make replication and reproduction easy for other researchers, because they just need to download your data to reproduce your findings, or download your materials to replicate it by collecting new data and trying again. So this much for now. I'd highly encourage you to have a look at a p-hacking tool that's linked below this video, because it can really help to bring the idea of p-hacking to life. And then I'm looking forward to seeing you back here for the third video.